Hello and welcome to the Data Engineering Podcast, the show about modern data management. What are the pieces of advice that you wish you had received early in your career of data engineering? If you hand a book to a new data engineer, what wisdom would you add to it? I'm working with O'Reilly on a project to collect the 97 things that every data engineer should know, and I need your help. Go to dataengineeringpodcast.com/97things to add your voice and share your hard-earned expertise. And when you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode, that's Linode, today and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For more opportunities to stay up to date, gain new skills, and learn from your peers, there are a growing number of virtual events that you can attend from the comfort and safety of your home. Go to dataengineeringpodcast.com/conferences to check out the upcoming events being offered by our partners and get registered today. Your host is Tobias Macy, and today I'm interviewing Martin Traverso about Presto SQL, a distributed SQL engine that queries data in place. So Martin, can you start by introducing yourself?
Yeah, hi Tobias, thanks for having me. So my name is Martin. I am one of the original creators of Presto back in 2012. I'm currently a CTO, one of the CTOs at Starburst. I've been working on Presto for the last 8 years. Before that, I worked at a couple of different companies, enterprise companies, consumer companies, social networking, and so on. So I have a bunch of experience in different areas of distributed systems and large-scale systems.
And do you remember how you first got involved in the area of data management?
I've been exposed to databases from pretty early on. Like from my first job involved databases in some form or another. But for many years, it was always transactional databases, like a database behind a website or some application. And it wasn't until around 2007 when I was at Ning that I started looking at Hadoop and the Hadoop ecosystem and brought it into the company to start experimenting with analytics there. Then over the next few years, I got to use like things like Hive and Hadoop even more until I ended up at Facebook in 2012, and that's when we started writing Presto, and I'm working on that system since then.
And so in terms of the Presto project itself, I know that it is, as I mentioned, a distributed SQL engine and that it doesn't do any data storage on its own, instead relying on different backing stores for handling the actual durability of the information. So I'm wondering if you can give a bit more about the overview about what Presto is and some of the origin story and why it was architected in that way.
Yeah, absolutely. And that is absolutely correct. Let me start by describing why we created Presto, and we'll give you a better picture of why we ended up where we did. So back in 2012, Dean Sundstrom, David Phillips, Eric Kwan, and myself formed a team at Facebook. I mean, we joined Facebook around that time, and we formed a team to try to solve one of the big problems they had in the data infrastructure at that moment. So people were using Hive almost exclusively. Hive came from Facebook, I don't know if you remember. And they were using that almost exclusively for any analytics they wanted to do, be it batch analytics, ad hoc, interactive. But the problem with Hive is that it's very slow. There was a famous quote from a data scientist at Facebook where they said, "It is a good day when I can run 6 Hive queries." So we looked at that. That was an awful experience. People were not being able to do their work effectively. So we said, okay, there's something we can do about this. So we set out to build Presto with the initial goal of tackling that interactive ad hoc user experience on top of the Hadoop warehouse. So we built Presto to be efficient at that. Actually, from the beginning, we decided we want to make it open source. And that posed a couple of challenges because Facebook had their own version of Hive at the time. They had forked the open source version internally. They had extensions, they had changes, and we need to be able to support both the internal version and also the external version and the open source version. So we said, okay, how do we go about doing that? And that's when we came up with the idea of separating the computation layer from the storage APIs. And we put a very simple and clean interface between the two, and then abstracted it out in what we call connectors. And we made the connectors pluggable. So you can drop in a new connector when you deploy Presto, and you can talk to a different data source. So that was kind of the forcing function. Then after that, other people like in the company, and then after we open sourced it outside, ended up using that as a way to extend and connect with a bunch of other different data sources. So we started with the goal of making analytics over Hadoop faster, but we ended up with a system that can query Hadoop and it can integrate with other data sources like Elasticsearch, MySQL, Oracle, Postgres, and run queries across all of them. In that sense, like Presto is the query engine, and then it delegates to all these other systems for the storage needs through these connectors and plugins I mentioned.
In terms of the release of it as an open source project, what was the motivation behind that? And how do you think that influenced the original ideas about how to approach the problem?
Dane, Dave, and myself have always been big believers in open source. When we started the project, we said we want to do something that will be a multi-decade project. We want it to be as successful as other projects you see out there like Postgres or MySQL. So we said we want to build something that stands the test of time. And the only way to do that is to make it open source. Like if you kept it inside Facebook, I mean, this is the kind of thing that it might be useful for a few years and then something else comes along and then it gets abandoned. People move from different team to a different team and it stagnates and so on. We want to make it open source so that we can get other people involved and it can grow beyond a single company and a single use case. I mean, that's kind of the motivation. And we wanted to build something that we didn't want to have to build again over and over. So making it open source was the right approach there. Now, of course, that places a bunch of constraints in the way we architect things and the way we develop things. There are a number of things that you would normally be able to do if the system was specialized for the use case, the single use case that you're trying to solve. But by making it open source and accessible to other people, we basically were saying, okay, we want to make the system more flexible. We want it to cater to the needs of other people. So there's a delicate balance we have to strike there. It requires creating these abstractions of connectors. It requires sometimes making trade-offs about what do we develop at a given point in time so that it can satisfy what other people need, not just what Facebook needs. Sometimes there was some complex sequencing the features and the way we approach them, because we may have someone from external to Facebook come and say, hey, I need this specific feature. And then we might be working on something. There might be if you don't do it carefully, there might be a conflict in terms of how the two changes fit together. So it's a lot more work. You have to interacting with people in the community a lot more. We have to coordinate things a lot more. And it can get also challenging when those people are all over the world, as opposed to sitting next to you in your office. So it has changed the way we approach the development and the architecture of the system, and also how we work with people as we advance the system.
For somebody who is responsible for architecting the data platform for their organization or considering how they want to handle data access to different sources or a single source, what are some of the signals that they should be looking to determine whether or not Presto will be a good fit for their environment?
There are two different approaches or places where people start from. I mean, you have people that are either starting from scratch, they're trying to build their infrastructure, so they have like greenfield, they can choose whatever technology they want. If you're considering doing that, and especially if you're going to be in the cloud, you're probably going to be looking at S3 or Azure Data Lake Storage or Google Cloud Storage for storing your data. Then you're going to be talking about, I don't know, if you're using Glue Metastore in AWS for your catalog and so on. Once you start considering those things, then Presto is a natural fit because Presto was designed to be able to work in that ecosystem. So if you're going to be picking anything from the Hadoop and Hive ecosystem, Presto is just a fit there. And of course, if you need interactive queries, if you're doing interactive queries and you need those to be fast, efficient, etc., Presto is a perfect fit. Now, if you're dealing with other data sources, that's a case where Presto can be useful. It really depends on how you're using those data sources. One of the things we've seen is people are trying to migrate out of those systems. And Presto can be a good bridge for that because you can connect Presto to those data sources and you can connect them to a data lake. And then you can over time migrate from one to the other and do it somewhat transparently. So you can move workloads and you can continue to use the same SQL interface to access both data sources, which is very convenient for users. It lowers the barrier of learning and so on. But if what you're thinking is you're going to keep all your data in one place, like let's say you have an Oracle instance and you want to use Presto for querying that data instead of going directly to Oracle, that might not be a good fit. Oracle can do much, much better job at optimizing queries than Presto trying to get data out of Oracle to execute the queries in the Presto engine side. So it's a question of, are you trying to integrate different data sources, or are you trying to front a single data source with Presto for some reason or not? So where Presto shines is, like I said, querying data lake data. It's very fast and very efficient. So if you're going that route, then Presto is a natural fit. If you need to integrate data across multiple data sources, that can also be a good use case for it.
For the cloud data lake scenario, one of the things that I've often seen as one of the challenges is the access controls and authorization of the different data sources. And is that something that Presto can manage itself, or is that pushed down into the underlying storage engines to determine what access is provided to the end user?
There are a couple of different modes Presto can work on. Presto implements the standard SQL access control model. So for every table, there are permissions. The engine checks for every table when a user tries to query it. You can check whether the user has access to read the data, different columns of the table, whether you can read the table, whether there's a concept of column masks and filters that can be applied. So Presto provides the framework, but ultimately it's up to the connector to decide how to store and check those actual permissions. For example, if you're dealing with Hive, with a Hive Metastore, you might have Ranger integration somewhere. So Presto can delegate the integration to Ranger to see whether a given user has permission to access a given table. If you're talking to Oracle or to a MySQL database, Presto it delegates into the connector, and it's up to the connector to go and check in MySQL or in Oracle whether the user has permissions. There's another scheme where we call it it's like a credential pass-through that allows the user to provide credentials for the backend database when they run the query. And Presto will not look at those credentials. It won't do anything with them. We'll just pass them on to the underlying data source. And then the underlying data source is going to authenticate against the data store and use those credentials to check whether the user has permission. So it's flexible. It depends on your constraints. There are some organizations where they want to constrain the access to the underlying data sources at the data source level. In some cases, they want to abstract that out inside Presto, and that's perfectly doable.
For the types of use cases, you mentioned data lakes or being able to integrate across multiple different data sources, but what are some of the other ways that Presto is often used and the ways that it fits into the overarching ecosystem of big data tools?
Yeah, so let me describe one of the things that we did at Facebook when very soon after we made Presto able to have connectors. One of our friends at Facebook, he was working on a team. It was the team building one of the backends for one of the user-facing systems. It was an in-memory data storage, and they were thinking of implementing their own SQL engine or their own query engine because they need to be able to analyze that data to see whether people were gaming the system, whether the algorithms were correct, and so on. So after we told him about Presto and you could have plugins, he said, okay, I'm going to try that. He wrote a plugin in a couple of weeks, and then in 2 more weeks, he had the system running in production. So he was able to integrate Presto with that in-memory storage and provide analytics for that system, for the team running that system within a month. And that has nothing to do with big data, Hadoop, or Hive, or anything like that. It was a completely different use case, and it was super powerful. Then after that, we ended up building a bunch of different systems on top of, or using Presto as the backend. For example, the A/B testing system at Facebook uses Presto as the analytics backend. This is a completely different stack, separate from Hadoop and Hive. There's another system where Presto acts as the analytics backend for a user-facing product for ads. So this is users that are running ad campaigns. They want to go and analyze their campaigns. They go to a website. They click a bunch of buttons, and that runs Presto queries under the covers. So this is kind of a completely different scenario where it's end user facing. It has high availability requirements. It has to be up 24/7, runs in multiple geographic locations. It has to return results within 1 or 2 seconds because there's a person waiting on their end of the web browser for the results.
And so I interviewed your colleague from Starburst, Camille, a couple of years ago at this point, and talked a bit about the underlying functionality of Presto and how it's built under the covers and some of the ways that you're supporting it at Starburst. But I'm wondering, what are some of the most notable changes or evolutions in the technical and community and ecosystem growth in that time?
One of the biggest changes is community-wise. Like the community has grown dramatically over the last couple of years. So after we left Facebook, we spent, especially Dave and I spent 10 months working on Presto full time on growing the community, consolidating the community. And it paid off. Like we have a lot more people all over the world involved in the project. So today we have more than 2,600 people on the Slack channel for Presto. So it's a lot of people interacting every day, be it for asking questions about how to do certain things when they run into issues, or people saying, I need this feature, or I'm interested in implementing this, how do I start? To even more involved and complex discussions about architecture and design and so on. So last year we ran 5 conferences. This is organized not just by us, it was in coordination with companies all over the world. We did conferences in India, in Israel, in California, in New York, and in Japan. This is a testament to how global Presto is across the world. It was actually very surprising to us how it grew and how much adoption there was all over the world. So in those 2 years, we had more than 5,000 code changes. So 5,000 commits into a code repository, which is pretty significant. That's about 25% of all the commits in the entire history of the project over the last 8 years. So in terms of technology improvements, one of the most notable things is the sheer number of connectors that we added recently. Like over the past year and a half or so, we added connectors for Elasticsearch, for Oracle, for BigQuery, for Apache Pinot, for Druid, Amazon Kinesis, and there's a few more, that MemSQL, and so on. So these are mostly community member contributed. Some of them were from specific companies, but most of them were from people that were interested in just working on something and contributing connectors for those. On the engine side, there have been a lot of improvements. Like there are some performance improvements, some architectural improvements to the way Presto runs queries. One notable feature is what we call dynamic filtering, which allows the engine to optimize queries that perform joins by learning what data comes from one side of the join and then using that to prune dynamically the data source on the other side of the join. So this can be a significant boost in performance, especially if you have data that is partitioned in Hive or if you're using one of the formats like Oracle or Parquet that have some internal stats that can be used to prune data sets. And then kind of related to performance, there's another feature called late materialization that got added that allows the engine to evaluate certain things more lazily, so it can avoid reading data from the underlying data source if it decides it doesn't need the data at runtime. And this is also another dynamic optimization that happens. It's not something that can be determined upfront, but as the query executes, it can say, well, if you have some data that's going to be scanned and filtered, then aggregated, but the filters don't apply, then it won't bother reading the data. Traditionally, Presto would read the data, then filter it, and then throw it away before aggregating, for instance. There are a number of other areas. Like in those 5,000 code changes, there have been hundreds of small changes and then a few big changes. And there are some other areas where we have seen a lot of improvement. For example, there's better support for cloud environments. There's better support for support for Google Cloud Storage and Azure Data Lake Storage is new in the past couple of years. We've added support for AWS Glue, for the Glue catalog. There have been a bunch of features that make it easier to run Presto in these various cloud environments. And then finally, there's a big push around security. We added support for column level security, column masks, row filters, but also there's a better support for different modes of authentication for clients. and securing the server, the Presto cluster end-to-end. For example, all the endpoints in the cluster are now secure behind credentials, and the UI is secured. The communication between the coordinator and the workers is also secure, which is something that many companies don't care about, but as Presto is being adopted by different industries like banks, financial institutions, they are very sensitive to these aspects, and that those are some of the changes that we've been improving over the past couple of years. And then one last one I like to mention is we added support for variable precision timestamps in the last few releases. This is something that we've been wanting to do forever. It's what most databases support, like go use Oracle or Teradata or Netezza, one of those. They all support variable precision timestamps, which allow you to have more granularity than milliseconds, which is what Presto has traditionally supported. And this is important, for example, for the financial industry. Like oftentimes they need to keep data with nanosecond granularity. Now that is possible with Presto. So that opens up the door for a lot more use cases and adoption.
And in terms of being able to deploy and scale a Presto cluster, as you mentioned, there's been a lot of work done recently to support different cloud environments. And I know that there's also been support added for things like cloud native infrastructure using containers and Kubernetes. I'm wondering, for people who are planning an installation of Presto, what are some of the considerations that they should be aware of in terms of the deployment and scaling, and some of the integrations that might simplify their work to maintain a cluster with high uptime and reliability?
First thing is that there is some basic support in the open source project, but most of the support for like high availability and integration with the cloud environments more natively, that's done by vendors. Like, for example, if you look at Starburst, there's an offering Amazon Marketplace, in the Google Marketplace. So that's probably going to be your best bet if you want like an out-of-the-box experience that's easy and straightforward. If you're trying to do it yourself, it will be more work. I mean, you're going to have to do all the things that those integrations do by hand, like in terms of how you do high availability for the coordinator. I mean, it can be done, but you'll have to orchestrate that yourself. All the integration with the monitoring and CloudWatch in Amazon and so on, you have to do it yourself. So if you want an out-of-the-box experience, one of the vendors is probably going to be your best bet. Then in terms of how you scale and deploy and scale and so on, there's a couple of things that are interesting to know. One of those is that Presto has been run at scale in many companies for over the past 8 years. And for example, at Facebook, we run clusters of about 1,000 nodes each. So that gives you a sense of how big you can make a cluster. And that's probably bigger than almost any company needs. Like, you just need to know that it can go that high, but you probably won't need it that way. There's a couple of considerations you have to take into account. Like, Presto can utilize machines to the full extent. It's parallel and multi-threaded internally. So if you have a machine with multiple cores, it will use them all. So if you're thinking of collocating Presto with other systems, then that's probably not a good idea. I mean, you want to dedicate entire machines to Presto itself. This is not an issue with in-cloud environments because you can just provision new machines and the provider takes care of that for you. But if you're doing that as an on-premise deployment, then you have to be careful with that. And similarly, Presto can use the network very efficiently. Like, you can drive the CPU and the network to the limits. So you need to make sure you have fast networks, interconnects between the workers, which again is typically not an issue with cloud environments. Like in AWS, as long as you're in the same region, you'll be fine. In Azure and Google Cloud is the same thing. But if you're on-premise, then you have to be a lot more careful about how you distribute your machines across racks. You don't want to run into top-of-rack limits and so on. So cloud environments make it a lot easier. You have to take into account those factors in on-premise deployments. And then one of the things, this is something that we learned at Facebook, it's generally useful if you have different use cases. For example, interactive, you have some people that in your company that need to do interactive analytics, like BI tools or dashboards or sitting in front of a console and typing a query, but you also need to have support for batch workloads. Then you may want to separate those into separate clusters. Like, the configurations for those are going to be different because you're probably going to have different SLAs in terms of response times and queuing and how long you're willing to let people wait for a query to start, and so on. So one of the best practices is to separate your batch and interactive workloads, and that makes it easier to manage them. It makes it easier to manage user expectations and to make sure that everyone's happy.
As far as the best practices for working with data within Presto, because of the fact that it can federate across these multiple sources, there is the possibility for being able to use it for some of the ETL capabilities to read from one table in one data source and then write it out to another. But what are some of the ways that people can potentially shoot themselves in the foot if they're not careful at how they structure their queries or structure the ways that they are working across these different data sources?
Presto is a very complicated system, so the short answer is it depends. Depends a lot on the use case, the requirements. It depends on what are your performance requirements, how many users are you going to have running queries, are your queries going to be big, are they going to be small, are they going to use a lot of memory or not, and so on. Ideally, if you can run Presto over a data lake and have all your data sitting there, that's going to be the most efficient way to do it, because Presto, the connector for the high data layouts and querying over S3 or Hadoop or HDFS, it's the most optimal one is the one that has received the most attention over the past 8 years. And of course, it's the one that can run the most parallel, utilize the resources most efficiently, and so on. So you're going to get the best experience if you do that. But of course, like not everyone has data, all the data in a single place in a data lake, and oftentimes they have data in different systems. Presto makes it possible to read from those other systems. But one thing you have to take into account is that you're going to be limited in many cases by the capabilities of the connector and how the connector can interact with those systems. For example, if you're using the MySQL connector, the MySQL connector goes through JDBC. JDBC is a single connection effectively per query against MySQL. That means that when you run a query in Presto that needs to fetch data from MySQL, it's going to be coming from via one connection. It's not going to be parallel. So if you're pulling a lot of data, you may be bottlenecked by that. So you have to take that into account. Now, there are vendors like Starburst have optimized versions of some connectors. Like, for example, there's an Oracle connector that is fully parallel. So you don't suffer from this potential bottlenecks from bringing data through a single connection. But there are still some limitations. Like you can't, if you run a complex query, the engine cannot push certain shapes or query shapes into the underlying data source. So you may end up transferring a lot of data from the remote system that may be taxing to that remote system. So those are some of the considerations you have to take into account. One thing we've seen is people use the ability to connect to these data sources to maybe query them occasionally. Maybe they have fast changing data on these other systems because they are very suited for that than Hadoop, which doesn't really allow modification of data very efficiently. And so in those cases, that's a good fit. Sometimes what they do is they use the ability for Presto to read from those data sources to mirror them into a data lake, and then they can query them efficiently from a data lake.
And another situation that people who are looking at Presto might be considering, either because they're building out a greenfield project or because they already have an existing data warehouse, what are the trade-offs of using Presto in its optimal configuration on top of a data lake versus a vertically integrated data warehouse solution and some of the capabilities that it might provide out of the box?
I think the main one is one of flexibility. Like if you're using a fully integrated warehouse, like for example, let's say you look at Redshift. Redshift has the ability, because it controls everything from the query engine all the way to storage and even the data formats and so on, it can optimize that to the workload that you're going to perform. The disadvantage of that is that in order to interact with Redshift, you have to load your data into Redshift before you can query it. So that limits your flexibility. Like it forces you to go through an extra step that you wouldn't otherwise require. If you want, in terms of flexibility, if you want to interact with that data through other tools, like for example, let's say you have Spark in your organization because you're doing a lot of machine learning or more complex processing that is not suitable for SQL, then if you have your data locked in Redshift, you can't take it out. Like you have to extract it into a different system before you can use it. So being locked into that specific solution, that once you have a lot of data, you can't get it out, and moving it or moving to another system can become more expensive. Now, of course, you need ETL in those scenarios. You can run a query in those systems. It can be fast, but with ETL, you have an initial delay of getting all your data into that system in the first place. So when you have a data lake, like you're going to have systems that land your data directly in the data lake, and as soon as the data is there, you can query it. You don't have to do any further transformations. You don't have to migrate it. You don't have to copy it, and so on. I think those are kind of the trade-offs. But again, of course, like it is going to be more feasible for a fully vertically integrated system to do things more efficiently than if you have Presto sitting on top of a data lake.
In designing a data lake, there are also considerations to be made as to what format you're storing it in. So whether it's just JSON data in a gzipped file, or if you're using Presto or ORC files, and what levels of compression to apply on the various aspects, and then how to lay out the partitioning scheme of what the directory structure might look like in S3, for example. I'm curious what you have found to be some of the useful pointers or references for being able to determine how you want to land your data into the lake, for being able to query it effectively with Presto, as well as being able to use it with these other tools.
Yeah, one of the things that you first need to understand is, how are you going to manage your data? Like, what is the life cycle going to be for your data? Like, if you have data, for example, at Facebook, we had this requirement that data over a certain number of days had to be removed from the warehouse. So in order to do that efficiently, you need to organize the data in a way that makes dropping all data efficiently. So one thing that's pretty common is to partition your data by date. So you're ingesting data every day, you create a new partition, and then when the data is over the retention window, you just delete a partition. You don't have to go and rewrite anything. You just drop some files from the data lake. So that's one consideration. But then another consideration is, how are you going to be querying that data? And that sometimes those things can be at odds with each other. There are some things that can help make that a bit more efficient. For example, Presto supports, when you're dealing with Hive and the Hive metastore and so on, it supports the partition schemes that Hive supports. And you can use that for pruning data efficiently. Like, for example, if you're going to be querying data by date, and always filtering by date ranges, then of course, if you partition by date, Presto will be able to skip all the partitions that don't participate in the query. If you have other criteria you're going to be querying over, and that's not a high cardinality data set or field that you're querying over, then you might be able to use partition for that too. For example, you may partition by day and by some other by geography, for instance, if you're querying by geography. And of course, if you have a high cardinality dimension or value you want to partition on, that could be a problem because you're going to put a tax on the metastore. So you don't want to partition, for example, by user. That would be super expensive. On the other hand, there's another feature in the Hadoop Hive layout that's called bucketing that allows you to distribute the data across the files in a partition in a deterministic manner according to a set of values. So that could also be useful for filtering data up front. For example, if you're querying, let's say you partition your data by date and then you bucket it by user into 1,000 buckets. When you run a query, if you're searching for a specific user, Presto can take advantage of that knowledge and narrow down the query to only the files that are candidates for that, containing that user. So that can reduce the amount of data transfer, the I/O, and so on significantly. And then, of course, if you're using things like formats like Parquet or Orc, which are columnar, it can further improve the I/O patterns and the network transfers because it can avoid reading columns that you're not going to use. Those files also contain stats about data inside Parquet or Orc is organized into what they call row groups or stripes, which is a group of rows. They basically have there's a footer associated with each of those row groups that contains stats about what's the maximum or minimum value for a given column in this row group. And the Presto engine can use that to skip the sections that are uninteresting dynamically. So recommendations use Parquet or Orc. Orc is the most optimized format right now for Presto. We're working on making Parquet better and hopefully as efficient as Orc. if you want to compress your data, you definitely want to compress your data. The two recommended algorithms are LZ4 or Z standard. Those are the best in their class of algorithms. So LZ4 is good for fast compression. It's very efficient, but it won't compress data as compactly as Z standard. And then Z standard is a efficient algorithm for high compression. So it's better than gzip. So if you can use Z standard, that's the way to go. And then finally, one thing that's important is if you're running queries that use joins, that have a lot of joins, you want to have stats. You want to be collecting stats. So if you're using the Hive Metastore and Presto and writing data through Presto, Presto will collect them automatically. If you don't, if you're writing data through some other system like Spark or ingesting it through another streaming system, you want to run the commands in Presto that will analyze the data and record the stats in the Metastore so that the cost-based optimizer can then use them to optimize the order and the joint type selection when you run your queries and run them more efficiently.
As you have worked to grow the project and worked with people both in the capacity as a consultant as well as helping to grow the community, what are some of the most interesting or unexpected or innovative ways that you've seen Presto being used?
I mean, at this point, there's almost nothing that surprises me anymore. But over the years, there were a number of surprising use cases. Of course, there's the ones I mentioned about Facebook. We touched on them a little bit ago, where Presto was being used for things that were not what we envisioned it for in the beginning. Like initially, as I said, we were targeting the analytic workloads over the Hive Hadoop warehouse, and over time, Presto was used for a number of other different use cases that had nothing to do with that. For example, the backend analytics engine for an user-facing ad product, or the analytics backend for the A/B testing system. So those are things that we didn't foresee, we didn't plan for, and they were a bit surprising. There's actually an interesting one a few years ago. I don't know if they're still, I imagine they're still using it, but there was a company, Akamai. They used to have a system for doing analytics over all the live events over the entire fleet of machines, so they can monitor the machines and see what's going on and troubleshoot problems and all that. They had a proprietary system that did some kind of distributed SQL on a few machines. And at a conference in, I think it was 2015, I was talking to one of the engineers there, and they were telling me how they were replacing that entire system with Presto. I mean, I don't know how far they went with that, but that's what they were doing. It's like, okay, this is something I never thought people would be doing. It's like, this is Presto being used for like analyzing effectively what's telemetry of systems and being able to do live analysis and analytics over those systems. So it's a completely different application.
And as far as your experiences of working on and with the project, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Well, I think there are a couple of things there. One is when we started the project, I had never built a database engine, neither had Dane, David, or Eric. So there was a lot of learning by trial and error. Like, of course, we looked at a lot of literature over the last 30 years that talk about different aspects of building a database system. The problem is that you look at those research papers and they are either, they tend to be very narrowly focused. So it's like trying to discern the shape of an elephant by touching the different parts of the elephant, right? Is a kind of that proverbial example. So it's like, it's hard to get a mental picture of how everything fits together. There's no one place where you can go and say, oh, this is how you build a database system. So there was a lot of learning by trial and error. And I mean, looking in hindsight, after 8 years of experience, there's so many things I would have done differently and so many things I would have approached differently in terms of architecture, design, and all that. Now, of course, we ended up in a good place. Sometimes we did things in maybe not the most optimal way or the best way, but I mean, one of the important things is being able to iterate and change the different parts of the system to keep evolving. I mean, and we're still doing that. There's parts of the system that are still legacy from back in 2012, 2013 that we want to eventually change, and we're doing that slowly. The other thing is, and this is a challenge that's related to what I mentioned before of how do you deal with building a system that you're trying to optimize for your company, but also make it open source and cater to what other people need. There's a tension there. It's like there's a pressure, internal pressure to do something that will solve a problem for Facebook in the short term, but it might not be the best thing in the long term for the project, or doing it in the way that would solve that problem in the short term, maybe taking a detour that will make it harder to back out in the future, right? So it's this interesting balance between how do we solve those problems that Facebook needed and still be able to build something that's general enough that will satisfy what everyone needs in the community. And of course, sometimes there were changes that came from the community that were in conflict with things that we were building. So having a way to talk about those things and figure out what is the right order for those things to go in, especially when there are changes in the same areas, you need to make sure that they are sequenced right and so on. When you have distributed groups of people working on the same project, it can be challenging. So that's kind of one of the main things that I think Presto has had as a challenge that maybe other internal projects at companies haven't had.
Going back to the case where somebody is considering Presto for their data infrastructure, what are the cases where it's the wrong choice and they would be better suited either going with a vertically integrated data warehouse or some other SQL engine or just using a dedicated database system?
Well, I think there's a couple of use cases where Presto is not a right fit, at least today. Like, for example, if you're doing streaming data and you want to do live queries over streaming data or even standing queries over streaming data, Presto won't be the right fit for that right now. Like, it's not capable of doing that. Like, eventually, it's one area where we might look into, but right now there are other systems, better systems than that. For example, you can look at Kafka, Flink, what Confluent is doing around Kafka may be more appropriate. Another area would be if you're doing machine learning. Like, Presto has a couple of functions for doing machine learning, but they are nowhere near the state of the art, and there's probably much better systems for doing that. Like, if you're using PyTorch or TensorFlow or even Spark, and you're trying to access all the raw data directly, like going through Presto is probably not the best approach for now. I mean, at least there's no good integration right now with those systems to be able to do that. So those are kind of the main, in terms of the use cases. Like, you probably wouldn't pick Presto for that. One of the things that we occasionally get asked is, I have a Postgres instance. I want to use Presto to query it. And it's like, okay, if you're just using one instance of Postgres, just go directly to Postgres. Like, there's nothing, like, it doesn't buy you anything to go through Presto. Like, aside from you get access to the SQL language features that Presto exposes, but you're going to be reading all your data from Postgres, and you're not going to be able to run your queries as efficiently as if you do them directly in Postgres. So that's also not a good use case. If you want to front your single database with Presto, instead of going directly to that database. Now, of course, if you're integrating different databases, then that's where Presto kind of a better fit.
One of the other questions that I have is the capabilities of Presto in terms of transactionality, particularly across objects in a cloud data store.
So Presto has some basic support for transactions. The challenge there is that it's really dependent on the capabilities of the connector and the underlying data source. Like, for example, one limitation that it has is that if you're running a query across multiple connectors, you won't get transactionality because there's no way to distribute transactions. Like, if you're writing, let's say you're reading data from Postgres and writing it to S3 and using the Glue metastore, there's no way to have a transaction across those systems. Now, within a single connector, that's the story is a bit different. For example, with the recent changes to improvements to the data lake connector, we support high transactional tables, which allow you to modify and insert into those tables with some transactional guarantees. Like, for example, if you're in the middle of a write, other people are not going to be able to read that data. So until that transaction is committed, you won't be able to read it. Or if the query fails in the middle, you're not going to have partially written data into that table. So that can be important for many use cases. There are still some limitations. Like, for example, in the Hive model, you still can't have transactions across tables. But again, it's limited to what the connector and underlying system does. Presto can do more than what those systems support, unfortunately.
And as you continue to work on Presto and help support it in its community, what are the things that you have in store for it and that you're most looking forward to releasing, both technically and in terms of the overall ecosystem?
I've spent 8 years already in the project, and when we created the project, our aspiration is for this to be a long-term, multi-decade project. So we want the community and the project to be healthy over long term. And we've seen a lot more people get involved and a lot more companies get involved over the past few years. And we want that to continue. So we want Presto to be, like, if you think of Postgres as a successful open source project, we want it to be like that. We want people to think, oh, if we're talking about analytics, SQL analytics, oh, that's Presto. And that's where we're trying to go with the community and the project. So in terms of technical things, like in the short term, there's a couple of features that we're working on, the rest of the community is working on. One of them is what we call complex operation pushdown into connectors. This is about extending the capabilities of the connector engine interface to be able to push down more than just simple filters into connectors. So, for example, if you have a query that involves aggregations and joins and an order by, we want to be able to, when the connector is capable of doing that, be able to push those operations into the connector and, of course, into the remote system. So, for example, if you're querying data from Oracle and you're doing a join between two Oracle tables, it's pointless to bring all the data into Presto, join the tables, and then filter the results and returns a small set, right? You're probably better off being able to formulate that as a joint query inside Oracle and then let Oracle do all the work with its indexes and optimized capabilities. So that's one of the things we're working on, is being able to delegate more of these complex operations to the storage systems that can support that. Another feature that we're working on is actually a revamp. We're doing a revamp of the way functions work in Presto. So right now, functions are pluggable into the system also, but functions have to be defined upfront when the server starts. So you can deploy a plugin, server starts, and the functions that are exposed by the plugin are available. Well, that's it. It's static. So what we're changing is the model, a way that allows functions to be resolved dynamically. Just like tables and views and other entities in a SQL catalog are resolved, we're extending the function system to be able to do that. This is super powerful. It allows connectors to, well, first of all, at runtime, when a query is run, resolve the function and then decide at that point whether the function is supported or not and how it's implemented. This can be useful, for example, if you have integration with other systems that provide functions and that where users can go and define functions. There's a system that LinkedIn uses where they bring in functions that are portable across Hive and Spark and Presto, and they are defined externally. And you want to be able to evolve that catalog of functions externally and make it available to Presto without having to restart the Presto server. So that's powerful from that point of view. And then, of course, it opens up the door for allowing users to define their own functions using the SQL function language or potentially any other language binding like JavaScript or Python or something like that. So this is kind of the baseline to be able to do that. That's going on right now, and it will be in the next few, hopefully the next few months. Then, kind of in the longer term, there's of course a desire to make Presto an even better fit for cloud environments. Like, for example, being able to take advantage of spot instances across different cloud environments that can reduce cost. There are some challenges in terms of architecture. We don't have any concrete plans right now, but these are some things that we've been discussing the past couple of years of what can we do to make the engine operate better in those environments where machines may disappear, but they are cheaper, right? And potentially in the future, like even other use cases, like, I know, can we do something with machine learning? Can we do something with streaming? Can we better support that? Can we support more granular fault tolerance, which will enable certain use cases like very, very long running queries or even streaming use cases and so on. But it's kind of a pie in the sky, like longer term ideas and vision.
And also for anybody else who is looking to learn more about Presto, I know that you recently published a book with O'Reilly along with some of your co-conspirators on the project, so I'll add a link to that in the show notes as well. And for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I would just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I think there are a couple of aspects to this. Like if you look at the ecosystem, data management ecosystem today, there's all the pieces there. All the pieces are available. You have excellent query engines, you have streaming systems, you have catalogs, you have visualization and BI tools. But one of the things that I think is missing is something that brings everything together into a coherent platform. You can cobble these things together, you can kind of connect them, but it's a lot of work to do that. It's cumbersome. But for someone that doesn't really understand that space, it can be a lot of effort. So I think that, providing that fully integrated experience is something that would be super powerful for if anyone were to do that. And then within that, I think the weakest part right now is how the data lifecycle is managed. For example, how do you go all the way from ingestion to how you store and optimize the data, how you expire it, especially when you're considering workloads, how do you organize and potentially reorganize and optimize the data to satisfy those workloads? As far as I know, there's nothing that is capable of doing that right now. At least, in kind of open ecosystem. Like, of course, proprietary systems may be able to do that, but I don't know anything on the open source side. And then, of course, there's one big thing is like, especially as this is something that we had at Facebook, as your data warehouse grows, you're going to end up with, and if you have a lot of users, like at Facebook, we have thousands of users, you end up with, hundreds of thousands of data sets. It's hard to know what the relationship between those data sets is, what's derived from what's duplicated. There's a lot of redundancy. So being able to make more sense of that can improve the efficiency, reduce the cost, and then also, reduce the cognitive barriers for people when they're faced with all those data sets and they have no idea where to start when they need to look at something.
Well, thank you very much for taking the time today to join me and discuss the work that you've done with Presto. It's definitely a very interesting project and one that has been very transformative for a large portion of the data ecosystem, and it's very important within the overall space there. Something that I'm looking to take advantage of in the near future as well. So I appreciate all the time and effort you've put in on that, and I hope you enjoy the rest of your day.
Thank you. Thanks for having me.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.